Okay, today we'll be looking at chemical equilibrium and Le Chatelier's principle. The Le Chatelier's principle states that whenever there's a disturbance to the equilibrium, the position of equilibrium will shift in such a way to minimize the equilibrium. So let me give you a very quick example. Let's say you have a balance where it's perfectly balanced with 5 kilograms on both sides. If let's say there's a disturbance of equilibrium on the left, you add in 4 kilograms on the left. Okay, to achieve equilibrium again, you need to shift equilibrium to the right. Okay, you need to shift 2 kilograms to the right to reach a new equilibrium where now there is a 5, 2 and a 5, 2. Okay, to achieve equilibrium once again. Okay, so once again, if there's a disturbance on the left, when there's increase in more reactants on the left, you need to shift equilibrium to the right to achieve equilibrium once more. Okay, so that's the first factor that affects the chemical equilibrium. So for example, if there's increase or decrease in the concentration of reactants or products. So for example, if you add in H2, there's an increase in hydrogen gas, you need to shift equilibrium to the right to remove this disturbance. So therefore, it will favor the forward reaction. Similarly, if you remove hydrogen gas, that means H2 decreases, equilibrium will now shift to the left to produce more hydrogen gas and nitrogen gas. Equilibrium will now favor the backward reaction. Now let's look at the next factor. What happens when you change the pressure of the gas? Okay, please take note that for changes in concentration as well as changes in pressure, the Kc and Kp will not be affected. Kc and Kp equilibrium constants are only affected by changes in temperature. They only change when you change temperature. Now let's look at what happens when you change the total pressure. Okay, so for example, if you increase the pressure of the system, okay, when you increase the pressure, okay, the system will shift in such a way to minimize pressure. So it will therefore shift to the side with less moles of gas, because moles of gas will result in greater pressure. The more gases there are, the more pressure there is. So therefore, if you increase the pressure, your system will want to seek to lower the pressure by shifting to the side with less moles of gas. So back to the same equation, N2 gas plus 3H2 gas, giving you 2NH3 gas. If you increase the pressure in such a system, it will shift to the right. Okay, it will shift to the right to favor the side with less moles of gas to decrease the pressure. So therefore, if you increase pressure, okay, it will shift to the right to favor this side because it has less moles of gas to decrease the pressure. Similarly, if you decrease pressure, if your pressure is decreased, your equilibrium will shift to the side to favor the side with more moles of gas to increase the pressure, okay, to minimize the disturbance. Lastly, let's look at how changes in temperature affects the equilibrium shifts. Okay, to understand how changes in temperature affects the equilibrium shift, you need to first understand whether it is an exothermic or endothermic reaction. So for example, this reaction here is an exothermic reaction. So what you need to do is, in your head, if it's exothermic, you need to add heat on the right hand side, because exothermic means it produces heat. So therefore, if you increase temperature, means heat increases, equilibrium must therefore shift to the left. So therefore, equilibrium will shift to the left to favor the backward endothermic reaction to absorb the excess heat. Similarly, if you decrease the temperature for such a reaction, the heat will decrease, and therefore it will shift equilibrium to the right to favor the forward exothermic reaction. Okay, in such a case, increasing temperature, okay, I'm looking at this. If you increase the temperature, it will shift equilibrium to the left, therefore Kc will decrease. Okay, increasing the temperature will decrease your Kc because your equilibrium is shifting to the left. Similarly, decreasing temperature will cause your Kc to increase. Now let's look at another example where it's a simple example where A plus B gives you C, and let's say this is an endothermic reaction. So if it's endothermic, your heat will be on the left. So if you increase temperature, if you increase temperature increases, equilibrium will shift to the right to favor forward endo reaction to absorb excess heat. Okay, and the reverse is true. Decreasing temperature will shift. Increasing temperature will shift equilibrium to the left to favor the backward exothermic reaction to produce excess heat. So this is how you make use of LCP to solve for these 3 different scenarios. Okay, very straightforward. This 1 minute of chemistry. I'll see you the next time.